Here it says use change of base formula to approximate the nearest to the nearest 10,000. So change of base formula says that if you have some log with a base that is not either 10 or e, which is in your calculator, then you can just use your common log, your base 10, with the number that you were trying to find originally, divided by the log base 10 of your original base. And that will give you what log base b of a is. So in this case, we have a log base 2 of 6.8. So to do this particular one, I'm going to just use my common log because that is in my calculator. Log base 10 of 6.8. And I'm going to divide that by log base 10 of that 2, which was my original base. It says to the nearest thousandth. Pay attention to your instructions because those are some easy points that will count off. They add up. I count a third of the points off for rounding errors. So if it says to the nearest thousandths, that is 10 hundredth thousandths. That is 3 decimals, which means you need to look at the 4th decimal and decide if you round up or stay put. So make sure that when you put this in your calculator, you also know that you're getting your rounding correct. So to solve equations with a variable in the exponent, you need to get the base of that exponent completely by itself first, and then you either need to use the log of that base and use change of base, or you need to use your common log and expand. All right, both ways will solve it to the same answer. So my base here that I'm talking about is 16. That is what is being taken to the power of something. So I need to get that 16 by itself, which means my first step here is going to be to divide both sides by 5, because that is what is with my base. All right, so I'm going to divide this left side by 5, and it will cancel out just that 5. And I will have that 16 to the r minus 7 by itself, which is what I'm trying to do. And then 25 divided by 5, of course, gives me 5. Now here is where there's 2 processes you can do. All right. My first process is I can do my common log of both sides. So I can say log and log, my common log, base 10, because that's in my calculator. If I do it that way, I can just expand it, right? My exponent comes out in front, so I have that r minus 7 here, and I have log of 16 here, log of 5 here. And now I'm just solving for the r. To solve for r, I'm going to have to divide both sides by that log 16. I have that r minus 7 equals log 5 divided by log 16. And then my final step is to add 7 to both sides. So in my calculator, I can do all of that. It's going to look like this. Log, it's going to open. We're going to say 5 divided by log. It's going to open in parentheses. We're going to say 16. And then we would add 7. All right. And you will get 7.5805. Notice these instructions say 10,000th, by the way. 10,000th is 4 decimal places. So pay attention to your instructions. All right, that is the first way you can do it. If you would prefer to use change of base that you just did, then instead of doing log base 10 of both sides, you're going to use whatever base you have. So you're going to say base 16. You would still, at this point, you still have to get the 16 by itself. So we don't skip this step up here. But now I'd say log base 16 of both sides instead of base 10. What this does is on the left-hand side, that actually cancels out the base 16 and the base 16 cancel. So log base 16 and exponent base 16 cancel each other out. And I just have the r minus 7. And over here, I have log base 16 of 5. All right? You just did that in the section above, right? You did change of base. So in your calculator, you know how to do that. So we add 7 to both sides. And so in your calculator, you're going to do the same thing. You're going to say, well, log of 5 divided by log of 16. That's how I calculate this. And then I'm going to add 7, which is exactly what we did there, and you would get the same exact answer. Okay, so you can use common log and expand, right? Pull the exponent in front, or you can use whatever log base you have been given and do change of base on the other side. It will give you the same answer. We're going to do one more of those so that you can see what that looks like. All right, so let's look at number 11. I chose number 11 because it's a little more complicated. My whole goal is, like I said, to get my base by itself. So I'm going to do everything that doesn't have that with it first. In this case, I'm actually going to move that plus 6 over first, right? So I'm going to move the plus 6 by subtracting it. On the left-hand side, I have negative 2 times 12 to the x minus 4. On the right, negative 19 minus 6 is negative 25. Are they giving me a decimal? And then I will get rid of this negative 2. Divide both sides by negative 2. So I have 12 to the x minus 1 equals 12.5, right? Oh, I thought you meant this part. Oh, yeah, it's a 4 there. I thought you meant that one. I was like, So at this point, I can do whichever process I did up here. I can either do the common log of both sides, or what base would I use if I used a different log? What's my base? Yes, so I say base 12. And 12 and 12.5 do not cancel, by the way. So on the left-hand side, log base 12, exponent base 12 will cancel. I just have x minus 4. On the right-hand side, I have log base 12 of 12.5. And then I'm going to add 4 to both sides. And in your calculator, again, you can use change of base here. You can say log of my big number that I was trying to find originally over log of my base plus 4. And that will give me my answer of 5.0164. So you'll notice those equations keep going, but they turn from exponential equations where the exponent is in a power, and they go to logarithm equations where all of a sudden your exponent is within a log. So if you are given an equation with something to a power, you're going to get rid of that base with a log. If you're given a log, you're going to get rid of it with a base, okay? So just like in the prior one, I need to now get my log completely by itself. So I am looking at this one. I need this right here by itself, okay? And so I'm going to look at what's happening to that. Well, a 10 is multiplying by that. So I am going to divide both sides by 10. All right? And I will cancel the 10 out here. On the left-hand side, I just have log of m plus 3. And on the right-hand side, I just have a 1. Okay? Bases cancel out bases. So now I need to decide what base does this log have. If you do not see a base, what is the assumed base for log? 10. So I am going to use an exponential base of 10, 10 to the power of log m plus 3, and 10 to the power of 1. Okay? On the left-hand side, my base 10 and my log base 10 cancel, and I just have an m plus 3. On the right-hand side, I need to do whatever it says. What is 10 to the first power? Just 10, right? So it's just 10 here. And now I have a fairly simple equation to solve. What's my last step? Yeah, I'm going to subtract my 3. And so m equals 7. And that is the correct answer. All right, so once again, my goal, I'm going to try to recognize what I'm trying to get by itself. So this right here is what I'm trying to get by itself. So what do I need to do first to get that by itself? Yeah, I need to add this 9 to both sides. On the left-hand side, I now have the log base 5 of 6k minus 6. And negative 7 plus 9 is 2. All right. What is my base here? 5. So my exponential base is going to be 5. So 5 to that power and 5 to this power. All right? On the left, exponential base 5 and log base 5 cancel. And I just have 6k minus 6. On the right-hand side, I have 5 to the second power. What is 5 squared?
25.
Yep. And now I have a really simple equation to solve here. So I'm going to add 6 to both sides. 6k equals 31. And then I'm going to divide both sides by 6. This is under the same section that says round to the nearest 10,000th. So you should get that k is approximately 5.166, and you are rounding 7. Really, the only difference between this and the group above it is that you have to condense first. So for those of you that did not do well on condensing on your quiz before, you need to pay attention to condensing here, okay? Before you can do the process of getting rid of your logs, you can only have one per side, okay? So on the left-hand side, I have 2. I have a natural log of x plus 15 and a natural log of x. So I have to condense those first before I can solve this, all right? So I am going to use my condensing. Remember, when it's addition, then I can multiply these two and make it one log. So I'm going to use natural log, and I am going to multiply x plus 15 and x within my log, okay? You go from addition to multiplication if you're going from multiple logs to one log, all right? I'm condensing to one log. And over here, I already have one log, so I can leave it alone. Now, what is my base here? E. So when it looks like this, I can actually do e to those powers of both sides. And in this case, both sides cancel. It may not always be that way, okay? It may be where you have to then take it to a power and solve just like we did in the section above it. But in this case, the e and natural log cancel here, and the e and natural log cancel here. And I have x plus 15 times x on this side, and I have 34 over here. And then I'm just going to solve. On the left-hand side, what do I need to do with that x? Yeah, we need to distribute it. So we have x squared plus 15x equals 34. And then I need, when I have a quadratic, meaning I have an x squared, you put everything to one side and solve by factoring. So we're going to subtract the 34. We have x squared plus 15x minus 34 equals 0. Factors of 34 that subtract to give me 15.
2.
Yeah, 2 and 17. Which one's positive? To get a positive 15. Yeah, the 17 will be positive. The 2 will be negative. You can check it. 17 and negative 2 multiply to give you negative 34. 17 and negative 2 add to give you 15. This is factoring from, actually we did it in Algebra 1, and we've done it this year. Solve by factoring. Once you've done that, set each factor equal to 0. So x plus 17 equals 0, x minus 2 equals 0. So x is going to equal either negative 17 or 2. I do need to check it. If plugging it back in makes me get a log of a negative number, then I have a problem, all right? So if I plug a negative 17 in right here, I have a problem, right? If you try to put natural log of negative 17 in your calculators, you will get an error, all right? If I plug negative 17 into here, I would get a problem, all right? So negative 17 is not going to work. My only answer is going to be 2. Now, just because you get a negative down at the bottom here doesn't necessarily mean it could cause a problem. So let's say I just had this group and I got negative 5. Well, if I just had this group and plugged in a negative 5, then it would be a positive when I came down to the actual log, right? But here, a negative 17 plugging it into this group causes a problem, even if he weren't there. Okay, so you do need to check them and make sure that it doesn't cause an issue when you plug it back in. Even if it's a positive, it could have been x minus 15 and the 2 would have been a problem. So make sure that they work. You're really going to be using your formula, that your final total that you have is going to be your initial amount times e to some rate times time. Okay? That's what all of these are going to be doing. This is for a period of time an island's population grows exponentially. If the continuous growth rate is 3% per year, and the current population is 1307, what will the population be 9 years from now? So we want the population 9 years from now. Our initial population that we're using is 1307. We're going to always use E here because this is continuous. It says continuous growth. Our rate is 3%. We want to make that 0.03. And our time is 9 years. And then you can do all of this in your calculator. You can say 1307 times, this is the number above your ln. It is going to usually open the exponent, and you're going to say 0.03 times 9, close parentheses. For population, how do you think you should round? To the whole. We're talking about people, okay? If it was money, how should you round? 2 decimal places. Money is dollars and cents. Other than that, it will usually tell you how to round, okay? So up at the instructions, it said round to the nearest tenth, right? So somewhere in the word problem or in your instructions, it's going to tell you where to round if it's other than a person or dollars and cents. So other than those situations, look to your instructions for your rounding, okay? But even though it said round to the nearest tenth, this was talking about population. So we're not going to do the nearest tenth of a person.